Hi, 8th graders, Mrs. Claire here. I am going to do your last transformation lesson. So you've done translations or slides, reflections, flips, rotations or turns. And this last one, or last transformation rather, is dilations. And dilations are different from those other three. The other three were called rigid transformations because when you moved them, they were still congruent to the pre-image. Now we are going to take that pre-image and create one that is larger or smaller. So it'll still be the same shape, but a different size, okay? You might want to have a ruler, maybe a couple colored pens to work with today. This is the set of notes that you're going to be writing on that you got from your teachers in class the other day, all right? So I would put down the date up at the top. And make sure that you keep it in your physical notebook so you can show your teacher when you get back to class, okay? All right, so dilation, that's one of the transformations that produces an image that is the same shape as the original. We're going to call that original the pre-image, okay? But it's going to be a different size. What makes it the same shape is that all of the angles, the corresponding angles, are congruent, but the sides are not, all right? Now, when we do a dilation, at least for this year, all those dilations we say are centered around the 0, 0 is the origin. So we dilate from the center of origin, we say the center of dilation rather is the origin. The center of dilation is the origin. Say that better for you, huh? Now, dilation is going to be similar or proportionate to the original figure. Remember that original figure is called the pre-image. Okay, so similar, again, same shape, different size. Right? So how is it bigger or smaller? It's bigger or smaller by a scale factor. So factor being a number that we multiply things by. So how do we know what that scale factor is? Well, we would take those lengths of their sides, for example, and put the new over the old. Okay, so this is our new length of the image that's been transformed over the original or old length, okay? And when we put them in a ratio like that, that ratio implies divide. We can divide it and get a decimal or a number. But this is a ratio because we're comparing two different numbers, right? If this scale factor is greater than 1, then that figure is going to become enlarged. And so it's going to get bigger, right? If we enlarge it, it's going to get bigger. Same angles, longer sides. If that scale factor is between, okay, 0 and 1, I'll just call it X. Okay. Actually, I should call it K, excuse me. There we go. Then that figure becomes reduced or smaller. So we say that we have a reduction or we have an enlargement. Okay. Now you do this a lot already when you change, if you take a window that you have open on your screen and you drag the corner. Okay, if you drag the corner, you're enlarging it and keeping the same shape, the same angles, right? But if you were to just drag one side, now it's going to be a different shape, right? Okay, well, let's talk about, by the way, before I forget, this scale factor, if we're saying it's between 0 and 1, I assume you know that just means it's going to be a fraction, okay? We can't multiply it by 0. And if we multiply it by a negative, that's not appropriate for measuring lengths, okay? All right, so the coordinate rules, remember, are going to be part of the tasks that you have to do to get your, go up on the levels that you get graded on. So coordinate rule is that we take our pre-image, X, Y, whatever those coordinates are, and we multiply them by, we're just going to call it K. It's some number, right, That is the scale factor. So if we're making something 2 times bigger, we multiply the coordinates by 2. So if coordinates are all a distance from the origin anyway, if we try to enlarge it by making it twice that distance, then all of the coordinates are going to be twice the distance from the origin, right? If we try to reduce it, let's say by half, then all of the distances that we would plot the points from the origin are going to be half that distance now, right? So it makes sense for us to say, all right, to change our coordinate, we would go from x, y, and we multiply everything by that k. So a rule would look like this. Take your original coordinates, perform this dilation, and it would yield whatever the scale factor is times the k coordinates, and whatever the scale factor is times the y coordinate. Okay, so that is our coordinate rule. So let's do an example here. If we have a scale factor of 3, how would you write the rule? Well, wherever our original coordinates are, we'll call them x, y for our pre-image, right? We perform the transformation, and what does it yield? What does it get us? Well, all of the x coordinates are going to be 3 times farther away from the origin, and all of the y coordinates are going to be 3 times farther away from the origin. So the sides are going to be 3 times bigger because of that. What do we say about the angles though? The angles are going to be congruent. It's the sides that are going to be proportionate. So the pre-image to the image, that relationship, remember, is that they are proportionate, they are similar. They're not congruent anymore like our first 3 transformations, okay? Pretty important to remember that. Okay, well, let's do this example without even drawing it. We can look at these coordinates for this triangle with vertices A, B, and C. Say, well, what will it be if we transform it by dilating it by a scale factor of 4? Okay. Well, all of these are going to get multiplied by 4 then. So if we started with 0, 2, and we transform it, it's going to be a scale factor of 4. K is the scale factor of 4 times 0 for x, and 4 times 2 is our y value. Okay, so what is that? That is the same as 0 and 8, right? For B, I'm not saying that you would have to show this work. I think you can probably do it in your head. We're going to multiply each x and y value by the scale factor of 4. So 4 times 4, and 4 times 4. Okay. And same thing with C. It was -1, 4. And if we multiply all these by a scale factor of 4, -4, and 16. Now what we have here are the A or pre-image coordinates. Over here are our prime, sorry, I guess it would be right here, coordinates. Remember that prime notation, kind of like the apostrophe to the side of it. Okay, so the transformed prime vertices, okay? All right, we're gonna flip this over and do a couple other examples then. All right, so example 3, we have these vertices for triangle PQR. And it's dilated by a scale factor of 0.5 or 1/2. So it's going to be a reduction, right? Because we're multiplying it by a fraction or a number in between 0 and 1, it's a reduction. So what are the coordinates of the image with P, Q, R prime, P, Q, I'm sorry, P prime, Q prime, and R prime? Okay. Well, we're going to take again all of the X and Y coordinates and multiply them, factor numbers that we multiplied by that number. So 1/2 times X and 1/2 times Y. That's the transformation we want to do on these coordinates. So P, our pre-image is -2, 4, and I multiply them by 1/2, which is the same as dividing by 2. Our prime transformed image will be 1/2 of -2 is -1. 1/2 of 4 is 2, right? We do it on Q, 4, 4, 1/2 of 4 for X and 1/2 of 4 for Y. And for R, 1/2 of 4 is 2, and 1/2 of -2 divided by 2 is -1. So those are our transformed images, okay? Let's say we take this PQR now and dilate it by a scale factor of 1.5. You're always welcome to use a calculator for this, okay? But I'm going to mark, and since we've already kind of done this one transformation, let's do this one with some double primes, all right? Okay. So 1.5 is we're going to maintain its original distance and go 50% farther. We're going to add that to the distance. So we could do that in our head, right? Or we could just say, all right, 1.5 times -2. That's our x value. And 1.5 times 4. For q, 1.5 times our x value of 4. And 1.5 times that y value of 4. And for r, same thing, 1.5 times x value of 4, 1.5 times this y value of -2, okay? So this is the transformation. It's going to yield these coordinates. 1.5 of -2, -3, 1.5 times 4, 6, 1.5 times 4, it's going to be 6. Lots of repetition makes that easier for us. We don't have to keep dragging out our calculator, right? Since we're doing it over and over here. Okay, 1.5 times 2, we've done that up here. Okay, so let's graph these 3 images. We have our original pre-image here, right? 0, 2, 4, 4, -1. I'm sorry. Yeah, these are our original coordinates right here, okay? So -2, 4 is just P, right? No notation there. 4, 4 is Q. And our last one, 4, -2 is R. Okay. I'm sorry, I apologize, you can't see any of that. So this is our pre-image. Now remember, sometimes when we're talking about pre-image, especially if we're not going to use the vertices, the letters, the reason, or the way that we know that it is the pre-image, if we don't have the letters to show us, hey, there's no prime notation, is that sometimes we shade that pre-image. So if you have pencil maybe nearby, you can shade this so we know this is where our pre-image was. And then we're going to dilate it from the origin. So everything is going to be kind of extending out from here, okay, from the origin in terms of enlarging it or shrinking it, okay. Let's do this one. We'll work our way backwards, okay? So this that I wrote in green, if we graph these, it's going to be bigger, right? You know, a lot bigger, but 1.5 times bigger. So -3 and 6, it's going to be here. And that's going to be, for us, it was a second or double prime, okay? Second transformation. Q is going to be 6, 6. And it's going to be Q double prime. And R we did was 6, -3. Right here. Is that right? 3. And that was our R double prime. Okay. So this was green. And you know, we haven't had probably a lot of transformations where there was this overlap. It's totally normal. I know it might feel weird to draw on top of these other images, but it's okay. This is why we probably want to do some colors though, right? So we can see them a little better. So this one was 1.5 times bigger. Let's go back and do this one, which was half. So dilated by half means it was a reduction. It's going to get smaller. Okay, let's see if I can move this up a little so we can get all of it in. Bear with me, guys. Okay, here we go. So half, here are our coordinates, -1, 2. I'm going to do this in red. -1, 2. And this was P prime. 1 prime. 2, 2. This was our Q prime. And 2, -1. This is our R prime. Okay. Do you kind of get a feel for how these are going to look, considering that they are centered around the origin? Okay. That overlap is just going to happen, right? Okay. The other one that we did was on this side where we made it 4 times bigger. I'm just trying to see if this would even fit on here, and it looks like it wouldn't fit anyway. So I think we're going to skip graphing this one, and we'll just keep these where we had our original, and then our enlargement, and then we had our reduction. Enlargement was 1.5 times bigger, and the reduction was half of that. All right. Okay, so these you want to hold on to. They should go into your physical notebook. You're going to need to show your teacher when you get back into class that it's been completed. So make sure maybe you get the date on there, your name, put it in your notebook, and then you need to move on to your practice, which are, I'm pretty sure, some slides that you need to submit in Schoology before you get back to class next Tuesday or Thursday, okay? If you need any help, make sure you are reaching out to your teacher for that, all right? And good luck to you.